Picture a Montana homesteader in 1867 standing outside his cabin at 4 in the morning, no barometer, no telegraph line within 60 miles, and a full harvest sitting in the field. By sunrise, he has decided whether to cut or wait, and he is right more often than the weather desk at the nearest city newspaper. He is not guessing. He is reading a system that took generations to build, and the question this video answers is exactly how he did it. Here is the timeline that puts everything in context. The thermometer was not invented until the early 1600s. The barometer came in the 1640s. Upper air observations, the kind that actually let forecasters see what is coming, did not begin until 1749 when a scientist lofted a thermometer on a kite over Europe. The electrical telegraph, which made it possible to share weather data across regions in a single day, only entered weather service in 1844. That means every farming decision, every ocean crossing, every military campaign before the mid-19th century was made with 0 instruments, every single one. The Smithsonian Institution launched what historians call the first systematic study of weather patterns in North America. Starting just after its founding in 1846, they built a volunteer observer network, farmers and postmasters and frontier doctors mailing or telegraphing daily readings back to Washington. Smithsonian staff turned those reports into early weather maps. That network eventually became the U.S. National Weather Service. But here is the critical detail. The frontier farmers feeding that network were still using their eyes and their instincts alongside any instrument they had, because instruments alone were not enough on the ground. Thomas Jefferson kept weather logs at Monticello starting in the 1770s, and his diaries are one of the most detailed records we have of how educated, instrument-owning people actually observed weather in early America. Jefferson had a thermometer. He even built a homemade hygrometer to measure humidity, but read his entries and you will find he consistently described days as thick, hazy, sultry, or fair, sensory language layered on top of whatever the instrument said. He was doing what every skilled observer did, using instruments where available and reading the environment everywhere else. So what were they actually reading? Start with the sky color. Because this is where most people think it is just folklore. Red sky at night, sailor's delight. Red sky in morning, sailor's warning. That rhyme is older than the New Testament. It appears in the Gospel of Matthew, and it has a real physical basis. In the mid-latitudes, weather systems generally move from west to east. A red sunset means dust and moisture are in the western air mass, which is the air that has already passed. A red sunrise means that same dust-laden air is now to your east, and what is coming from the west is the next system. The color is telling you the direction of the moisture. Cloud reading was not casual sky gazing. It was a structured classification system that farmers and sailors built from observation over centuries. High, thin, wispy clouds that streak across the sky like pulled cotton, what we now call cirrus, were understood as the leading edge of an approaching weather system, typically arriving 24 to 48 hours before the main event. When those high clouds thickened into a milky sheet and a ring appeared around the sun or moon, experience of observers knew rain was likely within 12 to 24 hours. The ring forms because ice crystals in those high clouds refract light, and ice crystals mean moisture is already overhead at altitude. The Inuit hunters of the Arctic developed one of the most precisely documented traditional weather systems we have on record, and researchers have actually measured its accuracy. A specific thin comb-like high cloud they called Pikaluyak arriving from the west was understood to signal a serious snowstorm within 24 to 36 hours. That is not a rough estimate. When researchers tested that single cloud type prediction against instrument records, the correlation held. These were not superstitions. They solved this centuries ago. The question is why we forgot. Wind direction was another primary instrument, and experienced observers read it from multiple sources simultaneously. The feel on the skin, the movement of grass and tree canopy, the behavior of smoke from a chimney, and the sound of wind over terrain. In North America, a steady wind shifting from southwest to northwest was a reliable signal of an approaching cold front. A wind backing from northwest to south, meaning rotating counterclockwise, often indicated deteriorating conditions. Pioneers who worked the same piece of land for years knew exactly which wind directions brought which conditions to their specific valley or ridge, and that local knowledge was more accurate than any regional forecast. Animal behavior was not superstition. It was the observation of creatures with sensory systems that genuinely detect atmospheric changes before humans can. Inuit observers documented that when caribou point their noses into the wind and refuse to settle, a storm typically arrives within about 12 hours. Seals hauling out onto ice floes in large numbers warned of a major storm roughly 8 to 10 hours out. Frontier farmers noticed the same pattern in domestic animals. Cattle bunching together and facing away from the prevailing wind, horses becoming restless and difficult to work, chickens refusing to leave the coop. These animals are not psychic. They are responding to measurable drops in barometric pressure that their bodies detect before any visible sky change appears. Sound carried weather information that eyes could not. On calm, clear days, sound travels poorly because warm air near the ground and cooler air above create a barrier. But before a storm, when a temperature inversion forms, sound bends back toward the ground and carries farther than normal. Pioneers knew this as a reliable sign. If you could suddenly hear the church bell from the next town or the river rapids sounded louder than usual, a weather change was coming. This is not folklore. It is basic atmospheric acoustics. The Inuit took this further, distinguishing at least 15 types of ice-cracking sounds, each associated with different weather changes, and in documented tests, sound-based predictions using multiple cues reached around 93% accuracy. Wind speed estimation without instruments is another area where traditional knowledge holds up against modern measurement. Inuit forecasters listen to the pitch of wind moving over snow dunes and estimated wind speed from the sound alone. When researchers measured those estimates against anemometer readings, the traditional observers were accurate to within about 5 miles per hour, 89% of the time. That is not a party trick. That is a calibrated skill built from thousands of hours of observation in a specific environment. Frontier scouts and experienced plainsmen developed equivalent skills for their terrain, estimating wind from the behavior of grass species, dust movement, and the sound of wind through specific tree types. Humidity was one of the harder variables to read without instruments, but even here, experienced observers had reliable proxies. Jefferson's homemade hygrometer was built on a simple principle. Certain materials absorb moisture from the air and physically change as humidity rises. Human hair lengthens, wood swells, salt clumps, rope tightens. Frontier people read these changes in the materials around them every day. A wooden door that stuck in its frame in the morning told you moisture content in the air was rising. Rope that had been slack the night before and was now taut told you the same thing. These were not metaphors, they were direct mechanical responses to atmospheric water content. Ice gave observers in cold climates a remarkably detailed picture of what was coming. Inuit hunters noted the appearance of tiny spiky formations called spicules on the surface of sea ice before warming events. These formations preceded warm spells in about 60% of documented cases, which is a meaningful signal when you are deciding whether to travel across ice that might become unstable. Frost patterns on windows and grass were read the same way by frontier settlers. Heavy, feathery frost on a clear, cold night with no wind often indicated stable, high pressure holding. A thin, patchy frost with wind suggested the system was already breaking down. Plant behavior was another layer of the system. Certain flowers close before rain because their petals are sensitive to humidity changes. Clover folds its leaves. Dandelions close their heads. Scarlet pimpernel, which old-timers called the poor man's barometer, closes reliably before wet weather and opens in dry conditions. These are not coincidences. They are evolved responses to atmospheric moisture that happen to be observable. Frontier farmers who worked the same fields for decades learned which plants in their specific environment were most sensitive and used them as daily indicators alongside everything else they were reading. The smell of rain before it arrives is one of the most universally recognized sensory weather signals, and it has a documented chemical basis. Petrichor, the compound released when rainwater hits dry earth, can be detected by the human nose at concentrations as low as 5 parts per trillion. Ozone from lightning strikes carries a sharp metallic smell that travels ahead of a storm front. Experienced outdoor workers learn to distinguish these smells and associate them with specific storm types and distances. A strong petrichor smell on a dry afternoon meant rain was already falling somewhere upwind. Ozone meant electrical activity was approaching, not just cloud cover. What made all of these individual signals powerful was combination reading. No single sign was treated as definitive. A red sunrise alone might mean nothing, but a red sunrise combined with backing winds, closing clover, restless cattle, and a ring around the moon the night before, that combination told a coherent story. Before we write it off as primitive, let us look at what actually survived. Generations of farmers, sailors, and hunters who made life or death decisions in environments where a wrong call meant a lost harvest, a capsized boat, or a party caught in a blizzard. The system worked because it was built on pattern recognition across multiple independent variables, which is exactly what modern ensemble forecasting does with computers. There is a reason this knowledge faded. It is not that it stopped working. It is that centralized forecasting infrastructure made local sensory skill feel unnecessary, and skills that feel unnecessary stop being taught. The Smithsonian network that started in 1846 eventually became a national system, and by the early 20th century, newspaper weather columns and later radio forecasts gave people the impression that weather knowledge lived somewhere else, in a government office, not in their own observation. That shift was convenient. It was also a loss. The old ways worked for a reason, and understanding why gives you something no app can replace: the ability to read your own land. If you want to start rebuilding this skill, start with one variable on your own property. Pick wind direction. Spend 30 days noting which direction the wind comes from before a rain event in your specific location. Write it down. After 30 days, you will have more locally accurate data than any regional forecast can give you, because regional forecasts are averaged across geography that does not match your ridge, your valley, or your tree line. That is how pioneers built their knowledge base. Not from books, from repeated observation of one place over time. The infrastructure for this is your own senses and a cheap notebook. If this kind of deep dive into forgotten practical knowledge is what you are here for, there is a lot more on this channel. We have covered how medieval builders engineered passive heating without any modern materials, how Viking longhouses managed thermal mass at -40, and what early American settlers knew about water sourcing that most people have completely forgotten. Hit subscribe and you will not miss what is coming next, because the next one goes into territory that most history channels will not touch. This is not fringe theory. This is documented engineering, and it is worth knowing.